Hello class and welcome to Module 8. This week we're going to shift away from databases and we're going to start having a look at APIs. We'll be doing APIs over the next 2 weeks. This week we're going to just learn how to connect to APIs and access APIs that are publicly available. Next week we'll actually be creating our own APIs. So what you want to pay attention to this week is what makes an API good quality. Ease of use and things of that nature, which again we'll go over more next week, but just pay attention to that as we access some existing APIs. So first question you might have is what are APIs? So API stands for Application Programmer Interface, and what they are is they are structured interaction points that allow systems to communicate to each other. The big advantage of APIs is that it allows you to have two systems that are controlled by two different parties have an agreement of communication between them. It allows the systems to be more loosely coupled, where if a team on one side changes something with their API, for instance, if they're the one providing the API, then the other team doesn't immediately have to react to that because they have an agreement through the API interface that that interaction will still work correctly. APIs are everywhere. You'll see that there's connection points with the public, from a company to the public, between companies, where one company is providing the API, the other one's consuming the API. It could even be bidirectional, where they both have APIs that they share with each other. Even between departments within the same company. And even smaller than that, there's a term that's becoming very popular called microservices, where you have a bunch of very small code bases or groupings of code that are self-contained but interact with other parts of the microservice infrastructure via API. And the big advantage of that is instead of having a monolithic large set of code to handle, you've got a bunch of very small groupings of code that are easier to maintain, upgrade, swap out, things of that nature. So topic 1, if you go on to Blackboard, just has some links and some information about APIs in general. Topic 2 is where we actually get to do some code, which is the fun part, of course. So let's access a public API. So I'm a big fan of SpaceX. I have been for a long time. So we are going to use a fan-created SpaceX API. There's a group of people that it's not SpaceX itself maintaining this API. It's just a bunch of fans of the company that maintain it, and they do an excellent job. There's a lot of depth to this API. We're just going to touch on it in a few different ways so you can see some of the cool stuff that's there. Again, being able to pull data into our program to be able to utilize it. First thing, before I even do SpaceX, just a couple of things here. I have to import the requests library. I believe it comes pre-installed with Python. It's been so long since I've had to install it, but if it isn't, you'll have to install it first and then import it into your program. Requests just allows you to make calls, web type calls. So I'm going to run this just to get that library imported. And then I'm just going to make up a fake URL and try to connect to it just so we can see what happens. So here I just created this request.get where I'm going to try to get this URL, which obviously doesn't exist. It's just totally made up. And then once I've made that call, the response information, which there's a whole bunch of information that comes with the response. I'm storing it in a variable called response. And then I'm going to just print out the status code. The status code is the response code. So if I run this, you can see, because this is totally made up, I get a 404. And that's just like if you were to load a web page with a bad URL or a URL that has been removed, you would get a 404. It just means can't connect. This doesn't exist. So that's great that I can see that programmatically, because I could react to that. Yeah, I could have my program say, if I get a 404 response, notify somebody or try again or something like that. So it gives me the opportunity to make adjustments. Now I'm going to actually make a real call to this SpaceX information API. And there's a link to the documentation in Blackboard if you want to look at this a little bit closer yourself. But it's the same structure as I just did previously. I'm using that response variable again, and I'm going to make a call to api.spacexdata.com. V4 launches latest. So I picked a portion of the API. There's a lot there, as I said previously. I don't know if I speak to this anymore, this module, but this is where one of the things that makes APIs really powerful for interacting between teams. When you maintain or own an API, there is an expectation that you will continue to service your documented API, even if you make future changes to that API. And it's not forever, but typically you would maintain a few versions backwards so that people that are relying on your API don't have to immediately react to a sudden change in your code. So this kind of versioning is very common in APIs. It would allow you to say, okay, we're moving to version 5. Let's say they're moving to version 5 perhaps. We will continue to support version 4 for, let's say, 6 months. And then you can notify everybody that's utilizing that API, either via notification on your site, or if you have customers or whatever, you can let your customers know, hey, this API is being deprecated. You need to get off of it or move to the newest version within such and such time, or it's not going to work anymore. It's a great way for two teams to be able to work together, but not have to be right in sync. So anyway, I'm using the version 4 API, and then this time I'm going to get a different response code because this is a real API endpoint. The response is going to be a 200, and 200 just means success. It successfully made the connection. Everything went well. There are different groupings of responses that kind of go together. 200s are typically success, but they could have a bunch of different information like 201, 202, whatever. 300s, I can't remember if that's denied. 400s are bad connection, 500s are access denied. I can't remember what 300 codes are. So you might have to just look up, say response code 200 on Google, and it'll tell you, what that code means. So if you're not sure why you're getting a weird response, it could help you. Okay, well, there you go. 200 means everything went well. Now let's have a look at the body of the response. So all we've looked at is the response code or the status code. Let's actually look at what it sent back, which is a ton of information. So if I go to the next cell, instead of doing response dot status code, I'm going to do response.json, which is the body of what they've sent back in the response. And there's a whole bunch here, right? I mean, and this thing looks like a dictionary with a dictionary inside of it. So this is a dictionary key. This is a dictionary value, which that has keys and values. Looks like I got some lists here, but this is all in JSON format. It just looks very similar. So looks like dictionaries nested within the list, nested within a dictionary. Not easy to read, but we can already see, if we look back, that there's some interesting information here. Like I can see there's, let's see, flight 8. I can see some dates. This was the static fire date. Here's some information. Looks like perhaps a URL that has some information, press kit. Like there's just a ton packed in here. And we wouldn't use all of this at all times, but maybe a subset of this information will be useful for us. So let's make it easier to read, first of all. We can bring in another library called the JSON library. And it's really nice because the JSON library will allow us to structure that in a much more readable JSON format. So I'll just run this. And you can see instead of just being a big clump of data, it breaks it down by the different groupings. So you can see much better how the data actually is structured, so at least be a little more readable. And the nice thing about this is I can access any of these keys and then be able to have the value that goes with it. And I'll do that by converting into a dictionary here in a moment. Okay, so that's everything in topic 2. It's just accessing it, getting that response, understanding that we can make that connection. On topic 3, we're going to get a little more specific because, again, an API that just gives you a giant blob of data in a very uncontrolled manner is not super useful because it puts all of the work on the receiver of the API to be able to parse that out. A well-structured or a well-created and maintained API allows you to say, I specifically want this information, and that API understands that and gives you specifically what you're looking for instead of just everything. It's also pretty inefficient if you have a large amount of data that every time somebody sends you a request, you send them reams of information. That's inefficient. If somebody specifically wants a thing, you should be able to, and it's a common request because your API, you have to think about how you do it. what's a common thing people are after, your API should be able to service that request. So we're going to continue working with that same API, but this time we are going to try to just look at information about Starlink. If you don't know what Starlink is a satellite constellation that is being put up by SpaceX to provide high-speed internet, much better than the existing satellite internet options because it's in low Earth orbit. They've already got something like 1,100 of them up, and they're continuing to put them up 60 at a time with each one of these SpaceX launches that they're doing. So I want to see some information about it. So I'm going to gather some information, then I'm going to use it to make another call for specific info. So here I'm just going to go to the Starlink endpoint for SpaceX data. So it's the same top level, still v4, but this time I'm going to look specifically at the Starlink information. And I'm not putting anything after that. And there's more that can go after that, but I'm just going to say, give me everything on Starlink. And then I'm going to immediately turn it into JSON view so we can have a look at it. Now there's a delay here because it is actually making a real-time call, requesting information, and then getting the response and processing it. So in this case, I get a lot. Like this is a lot. So you can see each one of these groupings is, I'm trying to find specifically what I wanted to point out, is an ID. So this from here up is the information that it's giving me back about one of the satellites. It's going to give this to me for all 1,100 of them. So it's the same data over and over again for each satellite. I mean, this is a lot of information all at once that I've just been able to pull down at a simple request. And I can keep going down forever here. But this isn't something I can really work with in its current format. I need to do a little bit of work on my side now to make this usable. So first of all, to be able to work with it comfortably within Python, I'm going to convert it so it's no longer going to be a JSON blob. It's going to be a Python collection. This just puts it into the formats that we're used to: lists, dictionaries, tuples, things of that nature that we already know how to work with. And I can do that by using .loads. So here you can see I've created a variable called Python.json, and then it's just JSON.loads my response information. And I have to do response.text because I only want the text portion of it. And then if I print this, it's again not going to look beautiful, because it's back to that really block structure because it's not pretty anymore. However, I can see that it's a list, and each item in the list is a dictionary, and then I think it goes to right here. This is all of that same information within a single item in my list. And then the next one, you can see every time it's a space track, it's the next satellite. So I've got all of that information in a giant collection. But it's in a workable format for my Python environment. So we can iterate over that collection and pull all the IDs, because the IDs, I know after looking at the API documentation, I can use the specific Starlink IDs to get information about a specific satellite instead of getting everything. So I'm going to do that. I'm going to just create a variable called Starlink IDs of type list, and then I'm just going to say for each of the items in my Python.json, that giant block, if that item has a key of ID, I'm just going to append it to my dictionary. And then I just wanted to see how many total I'd get. So it'll tell me how many, and then I'm just going to print it out so you can see it. It kind of looks funny, but you can see I've got 1,145 satellite IDs, and it's just each one is a satellite ID. So this is the IDs for everything. So I have now got all of the right identifiers to be able to call again to the API for a specific satellite. With our new list of IDs, we can now call the API with an added parameter to pull the data for the specific Starlink satellite. It's like I already know what I'm going to say before I say it. So for a single satellite, so I'm just calling it response.onesat, I'm going to do a request.get just like before. And I'm going to use an F string here because I'm going to build up my URL programmatically. So I got to convert it using an F string here. So here is the top level portion of it for Starlink. And then I'm going to insert the first Starlink ID in my dictionary, so index position 0. So it's going to take and replace all of this with, oops, with this right, oops, here, because this is the first item in the dictionary. So it's going to put that in the place of the other thing, and then it's going to make the call, and then I'm going to print out the response and in JSON format. So you can see I got a 200 response, which meant it successfully called the API and got the response. And then I just get the information specific to a single satellite. Personally, this lets me focus a little bit more because now I'm looking at all of the information I could get for all the satellites if I want to, but I'm just looking at a specific one. Things that interest me, like creation date, that's kind of weird. I'd like to understand more about that. Epoch is interesting. And then there is decayed and decay date. So I'm curious about some of these things. I'm going to pull some specific information and try to do an analysis on it, just to see just to point out, I guess, that I can do a very structured call response data analysis using APIs. So I'm going to first make a series of calls using each ID and pull out specific items of the response. Now, this is a little bit weird because you saw previously I had actually already called and got all of this information from the endpoint. In reality, I should use that to pull my specific data out, but that's not the point of this lesson. The point of this lesson is doing API calls. So let's just pretend I didn't have all that information and I just want to pull it specific for a specific satellite. Now, that does make sense because a lot of times endpoints, if they have a significant amount of data, they're not going to let you pull everything. They're going to let you only pull for specific IDs. So you would have to gather the information that you want via IDs and then pull it for specific ones. And that's important for them for throttling bandwidth and things like that. So people aren't just constantly pulling in large amounts of data. So here I'm just going to pull the information. I'm just going to grab 25 of the IDs because I don't want to make 1,000 calls to that endpoint. That's both impolite and it might lead to them blocking my IP if I look like garbage traffic. They might have something in place that prevents people from making a series of calls or a DDoS or something like that. So I don't want to push it too hard. It's just not good practice. So I'm going to create a variable called Starlink ID small. I'm just going to grab 25 of the IDs. I didn't want to grab 0 through 25 because those are the oldest satellites and the information is a little bit weird on some of those. So I grabbed 25 through 50, and then I'm just printing out to show that that's what I've got. Same thing as before, except a shorter version. Now I'm going to iterate through this list and make a call for each ID, as I just said. So here you can see, this time I'm going to store my result in a dictionary called sat-info-dict, and then I'm doing a for loop, and I'm saying for each item in my Starlink ID small. So I'm going to grab the first one, which is my first identifier in that list, my list, and then I'm going to make a call to that endpoint with that specific ID. So I'm building out my ID. And then as long as the satellite or the response is good, like I don't get a 404 or a 500 or whatever, I'm going to load the JSON into a variable, and then I'm going to pull the parts of that variable that I want. So I only want space track object name and space track launch date. This is the difficulty of digging into collections. Sometimes it gets a little bit complicated to try to get specifically what you want. This is multi-level, so I have to first look inside the space track variable, and then I have to, look inside the space track identifier, and then inside of that I need to pull the launch date. So that's why I end up with the 2 sets of brackets. So I'm grabbing object name, launch date, and decay date. And the object, I already got object name. I'm storing it into my dictionary for that ID. So I'm saying for my dictionary, with this key, which matches the identifier in the for loop, pull this information as the value. So I'm going to end up with key value pairs, the key being the satellite ID, the values being the information I care about. And if I get an error, print the response, or print the error, essentially. So this takes a minute because what it's doing is Python is single threaded, so it's making a call, waiting for a response, making a call, waiting for a response, making a call, waiting for a response, and then it does it 25 times. So it takes some time to get all this information into Python. Later this semester, we're going to do a little bit of trickery where I can take something that took, I don't know, 8 seconds here, and we could do it in 80 milliseconds by parallelizing our calls. But that's later. For now, we're doing it all in series. So I've got my data now. I've pulled it all into this variable, and I'm ready to work with it. So here's my new dictionary. And as I said, you can see I've got the key is the satellite ID, and the value is a list containing the Starlink ID and the date. This is the launch date, and this is the decay date. Next satellite ID, satellite name, launch date, decay date, et cetera, et cetera. So I've got all that information in a nice structured format where I can do pretty much anything I want with it. So I'm going to make some adjustments here because even though they look like dates, my Python program is not going to treat them like dates because it's not aware of that. So I'm going to actually officially say, hey, these are date times using the datetime module. So you have to import it. So from datetime, import datetime. And then for each item in my dictionary, if it has none, because there are cases where the data is dirty, they either don't have a launch date or a decay date. So as long as it's not none, then convert it into a date time with % year, % month, % day. And then again, for the second item, so this is for the launch date, this is for the decay date, as long as it's not none, convert it into a date time. And so if I run this, it's now updated my dictionary, and I think on the next, here's my new formatted dictionary, and you can see that instead of just looking like date times, they are officially date time objects. And the reason I'm doing this is because from the analysis I'm doing, I want to subtract them. I want to see how long the satellites are expected to be in orbit before they're expected to decay. So here we go. I'm going to calculate the expected time in orbit for each satellite where the data is available, because there are some that say none. So here is my little output that I'm doing. So total expected time in orbit, I'm just printing that, and then I'm going to iterate through that dictionary. And then it's this if statement. So if the launch date is not none and the decay date is not none, then print out, here's the satellite ID, here's the amount of time expected in orbit. Do that for every item in the dictionary. If any of them have none, then it just says TBD, so that you have something there in your output. So here we go. So I have been able to pull this information together with Starlink ID, and this is the amount of time, days, that it's expected to be in orbit. And you can see the ones where there is no decay date or no launch date, I don't know which. It'll just say TBD because I wanted to put something in there. It's probably been determined, I don't have the information. So I was able to pull IDs from an API. I was able to take that information, grab smaller sets of data from the API that are more specific to my needs, load it into a Python collection, and then manipulate that collection to get what I would consider an interesting output that I was able to come up with on my own. So it can be pretty powerful. So that's really everything here for this week. That's accessing APIs. You may find that it's not very difficult, and that's kind of the point. APIs are supposed to be easy to utilize. I do ask you to, in the assignment, there's a couple of assignments where I'm asking you to do something similar to what I've done here, as well as share an API that you know of or you are discovering, and some information about it. So again, as you go through that stuff, pay attention to what about the API makes it valuable? What makes it easy to use? Is the documentation very clear? Is the structure of the URLs very clear? Those kind of things are important for an API. Shouldn't have to sign up for anything or pay for anything. If you're trying to access an API and it's just really not publicly available, I would just move on. There are plenty of them that are publicly available and well maintained, just projects of love that people do. Or many times large companies will make APIs available because they don't want people to scrape data directly from their site, so they just make it available in an API format. Those kind of things are out there, pretty readily available. So go out, give it a try. Next week, we will be taking the API knowledge we've learned this way to try to build a decent API of our own using a tool called Flask.